Hello everyone, myself Anusha. So I am an IoT Internet emergency. So I'll be sharing what and all we did and the main project what we did as a IoT intern. So first we'll be starting with C programming. First we learn C programming and then we learned what is IoT and how it works, what are the applications of it, and then the main project that is home automation. So I'll be telling what and all were the requirements and how we solved it. So let us start with the C programming. So we'll be studying the basics and syntax and examples. What is C programming? So C programming was developed in 1970s by Dennis Ritchie. So C programming is like base for all the modern languages. Like all we have like modern languages now, like Java, Python, and other languages. For every programming language what we have now, so C programming is base for that. And it is used in many applications and also for system programming. And all the working for operating systems all have base as C programming. So next we'll start with the basic structure of C programming. So include stdio.h is like importing a library in Python, like the same thing we are doing here. Include stdio is like a library what we are importing it. So we have defined a main function here which prints hello world. So the slash n says that the cursor will point to the next line, and this function will return nothing, it will return 0. So you can see here on the right side, this is the hello world ka output. So we have return type as 0 here, and this is our main function. So next we'll be going towards the variables and data types. We have basic data types as well as the secondary data types. Basic data types are int, float, char, and secondary will be like string, array. We'll also learning it in further slides. So int main, we are declaring variables here. Age has a data type int, which is 25, and height is a variable which is of data type float, which is 5.9, and initial is a variable of char, a, capital A. So for strings, we can use double quotes. For characters, we can use a single quotes. And every line of code must end with a semicolon. That is very important. So otherwise, it may show a syntax error. So next, printf. What we are printing is we are printing age. So percentage d will is like we are typing the decimal, and slash n is move towards next line, and height will print with colon, and percentage 0.1f is for float, and next line initial, then percentage c is for character, and next line. So this will all print our 25, 5.9 and a. On the right side we can see the output of it. So next we'll move on to the operators. So you have many kinds of operators like arithmetic operators, relational operators, and logical operators. So in arithmetic operators like arithmetic algebra, what we have learned, like addition, subtraction, multiplication, division, and modulus. Relational, it will compare two characters or two variables. And logical and logical or and logical not. So we see few operations on the left hand side, the code and the output below that. So we are initializing int a with 10 and b is 5. So we'll perform an operation on addition, that is a plus b, which will return 10 plus 5, which is 15. And a is greater than b. So we are checking a condition here. So a is greater than b must return either 1 or 0. 0 means it will be false, 1 means it is true. In this case, it is true, that's why it's returning 1. Next is control statements. We'll learn about if else. So in main function, we have written a code to decide whether a number is positive or negative. So we'll check for 10. We're initializing num as 10. So then if my number is greater than 0, it will be a positive number. So in if condition, we are checking my number is greater than 0 or not. So if it is greater than 0, it will print positive. Otherwise, it will print non-positive. In this case, the 10 will enter our if-else condition. So 10 is checked with 0. So 10 is greater than 0. Yes, it will print positive. It will not go to else part here because the if condition is satisfied. It will print positive. Next is switch statements. So where we are going for multi-way branching. So syntax and use of switch and case we can see on the right side the code. So which is to decide the day is which day we are on, and the main function has int day is 3, and switch day case 1 if that is a Monday, if that's a Tuesday, case 3 if it's a Wednesday, and if nothing is satisfied default it will print a invalid day. So day is 3 here, that means case 3 is satisfied, so it will print a Wednesday. So next we'll move on to the loops. First we'll see the for loop. So for loop will have like initialization, then checking for the base condition, and then increment or decrement. So in this code we are incrementing it basically. So for int I will start from 0. It will check that condition that 0 is less than 5 or not. If that is satisfied, then it will print that and increment it, then come to the loop. So first it will print 0. 0 is less than 5 true. It will print that 0, and then it will come back to the increment it and come back to the loop. So now our I is 1. So 1 is also less than 5. Again print that 1 and increment it. So now our I is 2. So now it will check again the condition. So 2 is less than 5, yes. Then again print that and increment it. Like this. This will continue till 4. Why 4? Because 4 is less than 5. We have not mentioned the base condition as I is less than or equal to 5. If it was less than or equal to 5, it was printing 5 also. But here we have given it as only less than 5. So only it will continue only till 5. So next we'll move on to while loop. It is similar to for loop, but here initialization is there, then base condition, then increment. So we'll use the keyword while here. So I will start from 0. We'll check the condition 0 is less than 5. It is true, it will print that 0. Then more increment it, then it will print 1. Then it will continue like for loop, like as we saw before. So it is condition based looping. So next we'll move on to our arrays. So where we'll declare and initialize the things and accessing array elements. So we are initializing an array here. Here 5 is like size of an array which has 5 elements in array. For int it will, in first line we have initialized the array. In using for loop we are trying to access the array elements here. So for int I is equal to 0, I is less than 5, I plus plus. So this is like a basic for loop what we saw earlier. This will print every element in the array. So array of I in the square braces represent that we are accessing using the indexing. Here I will start from 0. Array of 0 is 1, array of 1 is 2, array of 2 is 3, array of 3 is 4, array of 4 is 5. So this will run until 0 to 4. It will print all the elements of the array. Next is functions. So functions, we have definition and declaration, function call and return. So whenever we are defining a function, within that we can pass the parameters where this will return a plus b. So we are defining the functions in first line, and then we are calling that in the main function. So we are initializing the function into a sum variable, then we are printing that sum. So int a we have passing the values as 5 and 10. So 5 plus 10 will be 15. So it will return 15 and it will print as a answer. So this was all about the C programming. So now we'll move on to the IoT, like basics of IoT, and we'll be learning what are the applications of it and how it will work basically. So introduction to the Internet of Things. So what is IoT? The Internet of Things refers to the network of interconnected devices that communicate and exchange data with each other over the internet. So here the main components are internet is main thing which we need. So the devices to connect with each other, we need internet. Without this, it cannot work. And we also need devices, not people. Here devices are getting connected. like how we connect to LinkedIn, Instagram, or any other apps, social media. Here devices are trying to connect with each other over internet. So key components we have like devices, like it can be a mobile, laptop, TV. Like these are the devices here. And connectivity is very important. And what and all they process with each other and how they connect. That's called data pre-processing. Processing basically. Then we'll learn about the key components of IoT. We have sensors and devices. Sensors will sense the environment. Sensors in the devices. It will collect data from the environment, what it is sensing basically. For example, temperature sensing. Thermometer, for example, it will sense the uh, temperature. What's the temperature of a human, maybe, for example. Next, connectivity. Like how we are connecting devices. We can use Wi-Fi, Bluetooth, or cellular, any other connectivity like this. That will transmit the data to the devices and will try to connect to the user. Data processing, analyzing and converting data into useful information. So whatever the sensors sense, that will be converted to the data that will be useful to us or to the user. From that, what is deriving, that will be sent to the user. Then user interface was interaction with the system via applications or dashboards. Like what we are seeing, that will be our user interface, what the user can see, the interface with the dashboards and applications. Then how it will work. Process flow. First, sensor will capture the data from the environment. Like we have sensors, like temperature sensor, or it can be any other sensor, or brightness sensor, or LDR sensors we have. We have many other sensors. So these will capture data from the environment. Then this data, whatever it has captured, that will be sent to the cloud service or any other local server. So this data will be sent to the cloud or any other server. Then data processing will happen. Whatever the data it has got, that will be pre-processed. And whatever it will derive from it, it will be sent to the user. Whatever information it has derived from that, it will be sent to the user. And action will be taken by the user. Whatever it has showed the information, based on that, the user will take the action. Next examples we'll see smart home devices like thermostats, lighting systems, and security cameras. These are some of the IoT devices. Then wearable device like smart watches, which can sense our like heartbeat. It can sense. Also, it can count the number of steps, how much we walk every day. And industrial applications will be like machinery sensors, like if there are any faults in the systems or the if there are any faults in any machinery, that will be sensed and it will be sent to the user or the administrator who is taking care of that. Then benefits of IoT. What's the use of what's the use of this using this IoT in our daily lives? Like efficiency is increased. Automation, like we are moving from 5G, we are in currently 5G, like we are automating everything. Optimization of processes, everything is optimized. We need not to take care of everything individually. Like someone is there to tell us something is going wrong, that is IoT. Convenience, enhanced user experience, personalized services. Data insights, like we can do better decision making through data analytics. It helps in decision making also. Then challenges, security. So sometimes there may be a data exposure, or somebody else or a hacker or an attacker is trying to access the private data, which is confidential. So then it has privacy concerns also, like someone is trying to collect our confidential data, which is not good. And interoperability, compatibility between different devices and standards. That is very important to connect. Connectivity is the main issue here. So we have to look into it that the devices get connected properly. Then smart homes, like we have smart thermostat that adjusts temperature based on user preferences. For example, ACs. Then in healthcare, we'll be attaching devices into the patient, which can track the vital signals and send to the data health providers. Health providers. Then in industrial applications, as I said, it can detect any fault in the machines. Predictive maintenance systems that monitor equipment health and predict the failures. Then trends in IoT like emerging technologies like integration with edge and edge computing and AI, 5G networks are there. So these are the future trends which we'll be seeing in IoT. Potential development, enhanced security will be there, improved interoperability, more intelligent devices. As we are integrating with AI, as we know that AI is in boom, it's a trending hot topic. So IoT can also be integrated with AI to get more intelligent devices. Thank you. Next, we'll be moving on to our project, OVIDA project. Yeah. MRC training project documentation framework. So we'll be seeing the requirements and design document. Finally, at the end, we'll be seeing the demo of the project, how we did, and what all we used. So overview, purpose. So this document outlines the requirements for the home automation using Arduino and Bylnk application. So for this, we'll be using the Arduino IDE and the Bylnk IoT application for this project. So this will serve as a reference guide for students developing the project and detailing functionality and goals to ensure alignment with the project objectives. So we will be also seeing the life cycle and also the requirements. So this project involves simulating a home automation system using a Picsimlab simulator. So we are using a Picsimlab simulator and we are trying to control various home devices. For example, we'll be controlling the garden lights, we'll be controlling the temperature, and we'll also be controlling the water tank. The system will allow users to manage home lighting, control temperature, and regulate the water level in a tank, all remotely through the app. So nothing we are going and doing individually, switching on, switching off, nothing we're doing. Everything using one single click will be doing this. Then assumptions, dependencies, and constraints. So assumptions, we are assuming that simulator accuracy is very high. So it accurately mimics the behavior of a real-world hardware component such as LDR sensor, temperature sensor, water level sensors. So these are the sensors we'll be using in this project. So network availability, the project assumes a stable internet connection for the Bylnk IoT application to function properly. So the connection between the devices and the Bylnk IoT app is very important here. For that, we need stable internet connection. Without that, this doesn't work. This will enable real-time control and monitoring of the simulated home automation system. So mobile device compatibility. The Bylnk IoT app is assumed to be compatible with the user's mobile devices with all features working as intended across various platforms. So that's why we are using Bylnk IoT app here. Next, assumptions. No external interference. It is assumed that there will be no external interference in the communication between an Arduino simulation and the Bylnk IoT app, ensuring smooth operation of the automation system. Dependencies. So we are depending on Bylnk IoT platform and Arduino libraries. We are using Arduino IDE to write our code in C programming. Then Picsimlab simulator. The performance, as we know, it has to be high. Then we are using serial communication. The system relies on serial communication for controlling the water tank inlet and outlet valves. Then constraints, simulation limitations. So if simulation is like it is not accurate, will not get proper results. So this is just a simulated environment, just we are checking how it works basically. So there is no interaction with real world hardware. So we are not using any real world hardware here. Just we are testing with our normal devices, like what we have created using the widgets. Then we have mobile app limitations. Bylnk IoT may have limitations in terms of number of widgets, response time, or data visualization would constrain the project's functionality. Scalability, the project is designed to control a small number of devices in a simulated environment. So we are not moving into like more devices. We are just seeing with it the three devices. Next, requirements, the functional requirements we'll see. First one is your garden light control, like how we are controlling the garden lights. This is like demo of it, like picture I have pasted here, how it works. So as you can see the LDR sensor, so like we'll be able to adjust the resistance here. So whenever the resistance increases, the brightness of the light must increase. It is brightness of the garden light must increase. So here voltage is inversely proportional to resistance. So whenever there is a high resistance, voltage will be very less. And also voltage is directly proportional to brightness of sunlight. So whenever there is less sunlight, the garden lights will switch on. That means resistance is very high. When voltage is low, resistance must be high. So in this case, this is a basic working of it. So the inputs will be like LDR sensor. The process is the system reads the LDR sensor's value. So it will sense the what is the brightness of sunlight, that will be sensed by the LDR sensor. So which reflects the current light intensity and adjust the LED brightness to simulate garden light responding to sunlight. So we'll be seeing at the end, we'll be seeing the demo of it, how it works. I'll be showing it. Then the output will be adjusted garden lights. So based on this resistance value will only we are trying to adjust the brightness of the lights. This is temperature control system. So temperature control system, we are using your LM35 temperature sensor, so which will be sensing the temperature. The temperature data from the sensor is read and displayed on both a gauge widget in the app and a CLCD screen. The green thing what you are seeing, this is your CLCD screen. On right side, what you are seeing is a Bylnk IoT application ka screenshot from my mobile. So this will be displayed on both CLCD as well as the Bylnk IoT app. Bylnk IoT app application, the temperature will be seen by a user. Outputs display temperature on the gauge widget on CLC. This will be the output. This temperature will be printed on both the Bylnk IoT as well as CLCD screen. And cooler control system. So cooler, we can see the widgets. Cooler switch on, cooler switch off. So like how it works. So these are the two widgets which we can see on the Bylnk IoT app. The system detects the button's logic level and turns the cooler on or off accordingly. So according to the user, this will be switched on or off. So output will be cooler status. So cooler status, it will print on CLCD whether it's on or off. And heater control system, you can see the widgets here. Heater switch on and off. The heater is similarly controlled via the Bylnk IoT app with a button widget that toggles the heater state. So input will be button widget on the Bylnk IoT app. The process, it again will the system monitors logic level of the button widgets and controls the heater operation. So threshold what we are maintaining is 35 degrees Celsius. The heater can't go beyond 35 degrees Celsius. So it's limiting to 35 degrees Celsius. So whenever it goes beyond that, the heater will automatically turn off. That is the threshold what we are maintaining here. Then that's what I was telling, the threshold temperature control. So as we can see in the upper screenshot, the temperature is 29.79. So where heater is on. But in second screenshot, T is equal to 35.64, heater automatically got turned off because it is able to sense that 35 is very high temperature and we have written code in such a way that it will automatically switch off the heater. So input will be temperature sensor. The system compares the current temperature to the 35 degrees Celsius threshold. So automatically the heater will shut down if the threshold is exceeded with notification set the Bylnk IoT on and CLCD. So next we'll be controlling the water tank inlet and outlet valve. As we can see the widgets here, inlet valve and outlet valve widgets, which user can use it to switch on and off. So water tank volume via serial communication. The system reads the water tank volume and adjusts the inlet and outlet valve based on the user's input from the Bylnk app. So the tank will fill up to 3000 liters. And whenever we're using it, the volume will decrease. So the minimum it can go is up to 2000 liters. And after 2000 liters, automatically the inlet valve will turn on. So below 2000, it can't go below 2000. So whenever it reaches 2000, automatically the inlet valve will on and outlet valve will be stopped. So this will be printing the volume, we can see printed on the CLCD. This is inlet valve control. So button widgets on Bylnk IoT app, we have it. The system detects the button's logic level and controls inlet valve according to the user how he wants. Inlet valve status and outlet valve control. Outlet valve is how much we are using it. The system detects the button logic level and controls outlet valve accordingly, similar to your inlet valve. So next, water tank volume control. How we are controlling the volume via serial communication. System monitors the water volume and adjusts the inlet valve to maintain the desired level. Like how much he wants, according to that, he can set the volume. So output will be inlet valve status and notification on water level changes. So for this, we'll be using serial remote tank. Then what and all user interfaces we have used. We'll be seeing it. There are many interfaces like Bylnk application and threshold control. So first one is Bylnk application. So serial communication, as we have seen here in water tank volume via serial communication. Here serial communication means it is used for transmitting and receiving the signal. So it's basically used for transmitting and receiving the signal. That's called serial communication. Next we'll be seeing about the user interfaces. The first one is Bylnk application. So where we'll be creating our widgets for heater, cooler, water tank values. So these display temperature, water volume in the tank. So terminal widgets, it will print what are the results what we get, like the temperature exceeds 35 degrees Celsius. But in this project, we are not using any terminal widgets. We'll be using the button widgets and guard widgets. Next is threshold control. As I said, the threshold for temperature is 35 degrees Celsius. So beyond which it goes, the heater will automatically turn off. And for water tank, 2000 is the minimum water level it can go, below which automatically the inlet valve will turn on and outlet valve will turn off. This is threshold control system. And Picsimlab simulator is used for the simulation, which it will allow user to simulate microcontroller projects, including those based on Arduino. So your IDE for writing code will be using Arduino IDE, simulating the Arduino environment, sensor, actuators, and displaying output on simulated CLCD. Like this is simulator, like we can see how it can work, how the sensors are sensing, and what are the outputs of it. Next is Arduino IDE. So the Arduino integrated development environment is used for writing and uploading code to Arduino compatible boards for simulations. So in Arduino code, how we'll write? We'll just write the code and we have to select the Arduino board over there. And then we have to check for errors also and debug it. And then we have to get the export compiled binary and then which will be loading it to the Picsimlab simulator, the code. Next is Bylnk IoT application. So this is like Internet of Things platform that allow user to control hardware remotely via a mobile app. So just using this mobile app, we can like control everything from this mobile app only. Then CLCD, which will display the results, which can display the temperature readings and water level status, and also the volume of the water. Then serial communication allows data exchange between the Arduino simulation and the Bylnk app. So this data exchange is very important. That is called connectivity. That's what I told, one of the challenges. And the Bylnk app or between different components in the simulation. This is very important. Serial communication between the Arduino IDE, and the simulation. And Bylnk app is very important to connect the devices. Gauge widgets, as I said, we are creating this in the Bylnk IoT app. This can be created for temperature and water level in an easy to read and dial-like format. Then we have button widgets for switching on and off the heaters and coolers. In conclusion, this project demonstrates a simulated home automation system using a Bylnk IoT application and Picsimlab simulator. The system effectively simulates a control of lighting, temperature, and water tank levels in a home automation. These were our three requirements in this project. The CLCD serves as a dashboard displaying the real-time status updates like for temperature and volume, and also what is the status of heater, cooler, and inlet and outlet valve. We'll be seeing the demo of it now. These are the output images like what and all you are printing. The left side you can see the Picsimlab spare parts screenshot, and on the right side you can see serial remote tank. Like will be seeing how the inlet valve will switch on, how the outlet valve will switch off. Like everything will be seeing here. Then these are my snapshots of a Bylnk IoT app. Like we have on the top, we have button widgets, and we also have gauge widgets for temperature, and button widgets for cooler switch, heater switch, and inlet and outlet valve. These can be controlled with just a single click. Thank you. Next, we'll be seeing the demo of it. I'll try to connect my laptop to the mobile. System. Now we'll be seeing the demo of it. This is my Bylnk IoT application. So I'm offline now. So let me try to connect, like become online. This is my Picsimlab simulator. Now we need this. First we'll start with the garden lights. I'll load my hex file. Home automation. So serial port should be COM7. Okay, my device is connected now. As you can see the yellow thing here, it means I'm online. First we'll see the working of garden lights. So as we can see here, so now we'll be seeing the demo of the project. So I'll be opening the Bylnk IoT app, and this is my Picsimlab. Currently we are offline, so we'll come to online. This is the Bylnk IoT app. We'll load the file, home automation, and then wait it for to connect to online. We'll open serial remote tank. This will connect to COM7. So still we are offline. We'll refresh the Picsimlab so that will be online. So we are offline. And now we are online. We can see the temperature. So automatically inflow is also on. So now just we'll see the working of the first requirement, that is garden lights. So as we decrease this, we can see the brightness of the garden light is decreasing. This is basically we are increasing or decreasing the resistance. When resistance is high, that means voltage is too less. At sunlight, we don't have any sunlight. That's why the garden light has more brightness. So when sunlight is medium, we'll have this much of light. So when we have more sunlight, that means more voltage but less resistance. And that time, no need of switching on the garden lights. So this was our first requirement. Second requirement will be our temperature control system. Temperature control system will be seeing it with this is a mobile screen. So now the temperature is 27.34 degrees Celsius. So now we'll switch on the heater. And also we'll also observe that so whenever the temperature reaches 35 degrees Celsius, the automatically the heater switch will turn off. So now we'll turn on the heater. Now we have turned on the heater. Now we can see that the temperature is increasing. The temperature is increasing. So whenever it reaches 35 degrees Celsius, automatically the heater will turn off. So as we saw that automatically as it reached 35 degrees Celsius, our heater got turned off. So this was our threshold control system for temperature. So now we can use the cooler. We can switch on the cooler. So as we see that the cooler is on now, it is showing cooler is on and cooler is also on. So now the temperature is decreasing. We saw the working of heater on and heater off. We also saw the working of the cooler on and cooler off. Now we'll switch off the cooler. Now cooler is off. So this was our second requirement, that is temperature control system. Now our third requirement is the water control system. So now we'll open the serial remote tank. So now this is our serial remote tank. So we have to also see the volume on the CLCD also. That's why we have to have the screen. So now the water level is up to mark. That is maximum is 3000 and inflow is also off, outflow is also off. So now I'll on the outlet valve. Now I switched on the outlet valve. So now we'll also observe that. So whenever it reaches 2000 liters, automatically the inlet valve will turn on. Outflow is on, it is showing outflow is on. Now we saw that automatically it switched on inlet valve. So without my intervention. So it automatically switched on. So up to, it will fill up to max, that is 3000 liters, and inflow is off now. So we'll see that again. So outlet valve I'll switch on. So whenever it reaches 2000 liters, automatically the inlet valve will switch on. Switching off the outlet valve. This was a third requirement. We are done with all three requirements, the demo of it. Thank you.